Hello viewers, in the previous video I have explained up to double displacement reaction, and today in this video I am going to discuss about oxidation and reduction reactions. Now what is oxidation? Oxidation is a chemical reaction which involves addition of oxygen or any other electronegative atom or ion to a substance, or removal of hydrogen or any other electropositive atom or ion from a substance. Now we know when magnesium reacts with oxygen, it forms magnesium oxide. Now if we balance it, it will be 2 here, here also 2. So when magnesium reacts with oxygen, it is going to form magnesium oxide. Now in this reaction, oxygen is added to magnesium, so magnesium is oxidized to magnesium oxide. We can say here substance oxidized is magnesium. Now here magnesium is oxidized to magnesium oxide because of oxygen, and these type of substances are called oxidizing agent. So if I write this one is oxidation reaction, this one is oxidation, then this oxygen is the oxidizing agent. So the substance that causes the addition of oxygen or removal of hydrogen is called an oxidizing agent. Now in this reaction, H2S is reacting with bromine to form HBr and sulfur. Now here H2S converts to sulfur. In this part, H2S loses hydrogen. Since hydrogen is lost, that is also oxidation. So here you can write oxidation. And since oxidation reaction has taken place, so this part is the oxidizing agent. What is reduction? Reduction is a chemical reaction which involves removal of oxygen or any other electronegative atom or ion from a substance, or addition of hydrogen or any other electropositive atom or ion to a substance. Now in this reaction, carbon monoxide is passed over heated iron 3 oxide and it gets reduced to metallic iron. Now in this reaction you can see iron oxide converted to iron. Since here oxygen is removed from the reaction, so this part is reduction. This part is reduction. So removal of oxygen is reduction, and since this reaction has occurred because of the presence of carbon monoxide, so this is the reducing agent. So we can say the substance that causes the addition of hydrogen or removal of oxygen is called a reducing agent. This carbon monoxide is one reducing agent. All the active metals like sodium, potassium, calcium, hydrogen, carbon, these are excellent reducing agent. In this reaction, hydrogen sulfide is oxidized to sulfur, already I told you, and here bromine is reduced to HBr. Since during the process hydrogen is added, so this is reduction, so hydrogen sulfide is the reducing agent. I think oxidation, reduction, oxidizing agent and reducing agent, these 4 terms are now clear. Now let me show you redox reaction. Remember students, the oxidation or reduction cannot occur alone. The oxidation and reduction, these two are complementary to each other. So when oxidation and reduction take place simultaneously, then this type of reactions are called oxidation reduction reaction or simply redox reaction. In case of redox reactions, the oxidizing agent is reduced and the reducing agent is oxidized. Say for instance in this example, copper oxide is reacting with hydrogen to form copper and water. Now here hydrogen is oxidized because oxygen added with hydrogen to form water. So this part is oxidation. So this is the oxidizing agent. Again, if you see copper oxide to copper, here oxygen is removed. Since oxygen is removed, so this part is reduction, so this is the reducing agent. So here substance oxidized is hydrogen, substance reduced is copper oxide. Now since this one is oxidation, so this one is the oxidizing agent, so copper oxide is the oxidizing agent and reducing agent is hydrogen. So in this reaction, both oxidation and reduction occur simultaneously, and as I told you, oxidation or reduction cannot occur alone. That means whenever there is oxidation, there must be reduction. So this type of reactions are also called redox reaction or oxidation reduction reaction. Now let me discuss about effects of oxidation reactions in everyday life. Now, the most important oxidation reaction that we see in our daily life is corrosion. Now, what is corrosion? Corrosion means it is the formation of layers of undesired compounds such as metallic oxides and metallic hydroxides on the surface of metal is called corrosion of metals. For example, we can say the formation of green coating on copper utensils, the formation of a layer of oxide on aluminium, the tarnishing of silver when exposed to hydrogen sulfide. All these are examples of corrosion. Corrosion is basically caused by the moisture. If the moisture contains carbon dioxide or hydrogen sulfide or any other reactive gas, then the process of corrosion gets accelerated and it takes place faster. Now I am going to discuss the corrosion of some commonly used metals. Let me start with aluminium and zinc. In case of aluminium and zinc, it is found that these two metals react with oxygen and initially a very thin layer of oxide is formed on their surfaces. But the corrosion stops. It is because the oxide layer in case of aluminium, these are very sticky in nature and hence form an impervious layer on the metal surface. And because of this layer, oxygen cannot mix with the metal anymore and corrosion comes to an end. In case of copper, it is found that when they are kept in moisture containing carbon dioxide for a long period of time, then a greenish coating is formed on their surfaces. It is because carbon dioxide gas in the presence of moisture and oxygen react with copper to form basic copper carbonate. In case of silver, it is found that a blackish layer is formed on their surfaces. It is because air always contains some amount of hydrogen sulfide gas, and this hydrogen sulfide gas reacts with silver to form silver sulfide, which is black in color. In case of gold and titanium, it is found that they do not corrode. If you see the metal activity series, it is found that they are placed in the bottom of the series. That means they are very less active. It is for this reason gold jewelry does not lose its luster. When corrosion takes place in iron, then we use a special term which is called rusting. It is the slow conversion of iron into hydrated ferric oxide in the presence of moisture and air. That process is called rusting. And what is that rust? Rust is the flaky, non-sticky brown powder that will be formed on the surface of iron when iron is exposed to moisture. When iron articles are kept in open air, after few days a non-sticky brown powder is formed on the surface. Those powdery substances are rust. Corrosion is a spontaneous, irreversible process and cannot be reversed or stopped. The corrosion of metals can be prevented by not allowing the surface of metal to come in contact with the moisture. This can be achieved by painting, greasing, enameling, varnishing, and by alloying. Corrosion can be prevented. The last topic from this chapter is rancidity. Generally, any kind of food gets rancid if kept at room temperature for around 24 hours, provided it is in contact with air. It is the oxygen in the air that oxidizes food and makes it stale. Rancidity, it is the oxidative deterioration of oils and fats leading to stinking, smelling or tasting like rank stale fat is known as rancidity. Now, different type of antioxidants can be used to prevent rancidity. In our home also we use chili powder, which acts as natural antioxidant. Nowadays in the market, butyrated hydroxytoluene or butyrated hydroxyanisole, this type of antioxidants are used in food items. Nowadays, snack manufacturers pack snacks in an aluminum bag. The air that is inside the packet is flushed out and then dry nitrogen is filled in, and this prevents oxygen from coming in contact with the packed snacks and they do not get oxidized. So this is another way by which rancidity can be prevented. I hope rancidity and corrosion, these terms are now clear. So dear students, already I have discussed combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and oxidation and reduction reaction. Now students, sometimes it is seen that during a chemical reaction heat is released. Again, there are some reactions in which heat is absorbed Based on that, we can classify the reactions into exothermic or endothermic. Now, a chemical reaction that proceeds with the release or evolution of heat energy is called an exothermic reaction. Say for example, carbon dioxide gas reacts with water to form carbonic acid. Formula is H2CO3, and it is always seen that during the reaction, small amount of heat is released. Since during this reaction, heat is released, so it is an example of exothermic reaction. Now we know the main component of biogas or CNG is methane. Formula is CH4. CH4. When methane is burnt, it reacts with oxygen, and during the process it releases carbon dioxide, water and some amount of heat. So during this reaction also heat is released. So these are examples of exothermic reaction. Again, the chemical reactions that proceed with the absorption of heat energy are called endothermic reaction. Say for instance, if we take carbon dioxide gas, CO2, this carbon dioxide gas reacts with hot coke. C means carbon here, you can write here coke. It must be hot. During the process it is found that it forms carbon monoxide with the liberation of heat, so you can write minus heat. During the reaction heat is absorbed, so it is an example of endothermic reaction. We can consider another example. Suppose when steam reacts with red hot coke, coke we write carbon C, this is coke. When it reacts with steam, steam is H2O, it will be in the gaseous state. So when coke reacts with steam, then it forms a mixture of carbon monoxide and hydrogen, and during the process also it absorbs some amount of heat energy, we can write minus heat. Okay, so when coke is passed over steam, then it forms carbon monoxide and hydrogen with the absorption of heat energy. So this is also an example of endothermic reaction. And that's end for today. In the next video I am going to start chapter 2 of chemistry. Till then, bye bye, take care and wait for the next part.